Alcohols are organic molecules that contain one or more hydroxyl groups attached to a carbon atom or atoms as shown in the illustration. By contrast, phenols contain one or more hydroxyl groups attached to a carbon in an aromatic ring. In phenols, the carbon attached to the hydroxyl group is sp2 hybridized. Alcohols and phenols can be classified based on how many hydroxyl groups are present. Monohydric alcohols and phenols have one hydroxyl group. Dihydric alcohols and phenols have two hydroxyl groups, while trihydric alcohols and phenols have three hydroxyl groups. Monohydric alcohols can be classified on the basis of the nature of the carbon atom attached to the hydroxyl group. These carbons are either sp3 or sp2 hybridized. We will first consider hydroxyl groups attached to sp3 hybridized carbons. In a primary alcohol, the carbon attached to the hydroxyl group is linked to one other carbon-containing group or to none of the carbon-containing group, as shown in the illustration. In a secondary alcohol, the carbon to which the hydroxyl group is linked is attached to two carbon-containing groups. In a tertiary alcohol, the carbon linked to the hydroxyl group is bonded to three carbon-containing groups. An allylic carbon is a carbon atom bonded to a carbon-carbon double bond. Note that the allylic carbon is sp3 hybridized. An allylic alcohol has a hydroxyl group attached to an allylic carbon. Allylic alcohols can also be characterized as primary, secondary, or tertiary. As we saw before, a primary alcohol has one other carbon group attached to the allylic carbon. Secondary allylic alcohols have two carbon-containing groups joined to the allylic carbon. Tertiary allylic alcohols have three carbon groups bonded to the allylic carbon. A benzylic carbon has an sp3 hybridized carbon bonded to an aromatic ring. Thus, we can describe a benzylic alcohol as having a hydroxyl group attached to a benzylic carbon. The molecules illustrated here are examples of benzylic alcohols. Benzylic alcohols can also be classified as primary, secondary, or tertiary, depending on the number of carbon groups bonded to the benzylic carbon as shown. Here is a problem for you to try. Classify these alcohols as primary, secondary, or tertiary alcohols. Molecules A and B are both secondary alcohols. In both A and B, the carbon bonded to the hydroxyl group is attached to two other carbons. Molecules C and E are tertiary alcohols. The hydroxyl bonded carbon is bonded to three other carbons. Molecule D is a primary alcohol. Only one carbon-containing group is attached to the hydroxyl bonded carbon. A vinyl carbon is a carbon atom double bonded to at least one other carbon atom. Vinyl carbons, which are also called alkenyl carbons, are sp2 hybridized. A vinylic alcohol contains a hydroxyl group attached to a vinyl carbon. Note that the vinyl carbon is sp2 hybridized. Can you classify these structures as allylic or vinylic alcohols? Structure A shows a vinylic alcohol. Notice how the hydroxyl group is linked to a carbon participating in a carbon-carbon double bond. Structure B shows an allylic alcohol. The hydroxyl group is bonded to a carbon that is adjacent to a carbon-carbon double bond. Now that we understand the classification of alcohols, let's turn to their nomenclature. The common names of alcohols are derived from the name of the alkyl group with a Y, L ending, plus the word alcohol. For example, the alcohol with the formula CH3OH, shown on the left, is commonly called methyl alcohol. It contains only one carbon, which corresponds to a methyl group. The molecule on the right has a 4-carbon chain in a straight line. This corresponds to N-butyl alcohol, where the N indicates an unbranched carbon chain. In IUPAC nomenclature, the alcohol name is derived from the alkane name of the longest continuous carbon chain. Drop the E from the alkane name and replace with the suffix OL to determine the alcohol name. The location of the hydroxyl group and additional substituents are indicated by using the numbers of the carbon atoms to which these are attached. Let's look at the same molecules we used a little while ago to learn about common names. In the IUPAC system, methyl alcohol with the formula CH3OH is called methanol. N-butyl alcohol is called butan-1-ol. Give the IUPAC names of these structures. Try to find the names on your own before checking the answers. When naming organic compounds, remember to find the longest continuous carbon chain. Start counting the carbons at the end of the chain nearest to the hydroxyl group. In molecule A, the longest continuous chain has 5 carbons. Start counting from the right-hand side of the molecule at the end nearest to the hydroxyl group. Notice that the hydroxyl group is on carbon 2. There is a methyl group at carbon 3. So, the correct name of this molecule is 3-methyl-2-pentanol. In molecule B, the longest continuous chain has 8 carbons. If we start counting carbons at the left end of the chain, closest to the hydroxyl group, we see that the hydroxyl group is on carbon 3 and there is an ethyl group on carbon 4. So the correct name of the molecule B is 4-ethyl-3-octanol. Some alcohols have multiple hydroxyl groups. To name diols and triols, start with the alkane name of the longest continuous carbon chain that contains the hydroxyl groups. The E of the alkane name is retained, and the ending OL is added. The appropriate multiplicative prefixes di, tri, etc. are used to indicate the number of hydroxyl groups present. Numbers in the name then give the locations of the hydroxyl groups. For the example shown here, the longest continuous chain has 5 carbons. We have to start numbering carbons at the right, closest to the hydroxyl groups. Notice that the hydroxyl groups are attached to carbons 2 and 3. So, this molecule is named 2,3-pentane-diol. Alternatively, you may see it written as pentane 2,3-diol. Can you write the IUPAC names of these alcohols? Try to do this on your own before proceeding. Remember to work backwards from the longest continuous carbon chain that contains more than one hydroxyl group. Molecule A has a 4-carbon chain and 2 hydroxyl groups attached to carbon 2. Hence, its IUPAC name is butane 2,2-diol. Molecule B has a 3-carbon chain with 1 hydroxyl group on each carbon. Its IUPAC name is 1,2,3-propane-triol, and the common name is glycerol. Molecule C has a carbon backbone containing 6 carbon atoms. Counting from the right, there are hydroxyl groups